Hello, everyone. I'll be presenting on AI blockchain synergy, secure coordination, and incentive aligned intelligence. So, one of the first things we do in this study, we carry out a literature review on studies which focus on AI enhanced blockchain and studies which focus on blockchain enhanced AI. And then we see that only one study looks at both AI enhanced blockchain and blockchain enhanced AI, which presents a gap, particularly because their study presents a tool and also giving some issues with AI in terms of governance, coordination, and incentives, and also issues with certain blockchain protocols. They are complementary technological systems. So, in terms of the approach we take, we survey a number of papers. At the moment, we're on our 53rd paper, but we expect this to be only a third of the actual literature, or probably half. And in terms of the process, so we searched on Google Scholar and other related databases. We screened mostly starting from 2020, and then we extract information and then we classify and analyze. And one interesting thing in terms of our approach compared to previous studies is we categorize blockchain and AI stacks into five layers each. On the AI side, we have the application, inference, model, data, and infrastructure layers. And on the blockchain side, we have application, execution or contract, consensus, network, and data layers. And why we do this is to see on what layers are of particular interest when it comes to enhancement, and also to look at the enhanced layers as well. So for the AI application stack, mostly governs how AI is embedded into workflows. For inference, it executes and serves as training models with monitoring and verification. Model encodes control knowledge through construction, training, and governance. Data basically prepares structures and governs how information is made available to the models, and infrastructure provides the computational resources. And on the blockchain side, we see application, which is mostly user-facing functionalities, such as like DEXs. And then we have execution or contract, which processes state transition information via VMs, virtual machines, and smart contract logic, consensus, network, and data. And then when we look into AI-enhanced blockchain on a very high level, we see that the reinforcement learning adaptive governance, and this occurs on the consensus, network, and application layers. There's deep learning for detection and analytics, the network and execution layer, LLMs and generative tooling on the execution and application layer, and AI-based consensus designs on the consensus layer, and then classical machine learning and hybrid approaches. And then we also have more or less examples of this, like the algorithms used on the AI side, deep learning or LLMs or machine learning. So we just analyze all this information. And then some of the things we find in our initial analysis is that the execution layer is by far the most AI enhanced layer, not by far, rather, slightly higher than the consensus layer, constituting 34.8%. And then we have the consensus, network, application, and data layers. And when we think of the execution layer, mostly security, smart contract, vulnerability detection, bytecode auditing. For consensus, is throughput optimization and trust sustainability. Network includes congestion control, anomaly detection, and resource allocation. And for application layer, we see mostly around DEXs, oracles, DeFi analytics, and then we have the data layer. But while we analyze on this orthogonal side, we also analyze on another side, to find that security constitutes significantly for AI enhancement of blockchain is mostly on the security axis. We also have others such as scalability, extendability, and sustainability. And then when we look in layer by layer, we see 80% of the studies target execution, application, or consensus layers. For execution and application layers, we see for application layer, we see things such as oracles, DeFi analytics, DEX, and AMMs. And then for execution layer, mostly smart contracts. And then for the consensus layer, there are lots of interesting studies that investigate how AI is used to dynamically tune consensus parameters and used to adaptively shard the chain performance, and also in fork monitoring. And then when we look on the blockchain enhanced AI side, we see on a high level, we see smart contracts and tokenization encompassing the data model and application layers of AI, consensus and on-chain validation encompassing the model, inference, and application layers of AI, privacy preserving mechanisms such as ZKP and secure multi-party computation on the data model and inference layer. We also have off-chain storage and hybrid architectures on the data model and application layer, and then identity and reputation systems on the data and application layer. So what we're essentially trying to do is to look for patterns, gaps, opportunities, and possibly replicating some of this enhancements methods on different layers, just looking to see what the gaps are. And we also would be going more granular over time. So at this stage, we're still on the first level, more or less looking at the main layers like the application inference model, data and infrastructure layer. But over some time, we would also be looking at the components. For example, this is the AI mechanism, mostly illustrated showing the life cycle. So we also be looking at the components and the flows within the components. And we can see on a very high level, blockchain mostly provides coordination and incentives to the application layer, verifiable inference execution for the inference layer, on-chain registry, ownership, and governance for the model layer, identity proofs and audit trails for the data layer, and decentralized compute coordination and incentives. And one thing to add as well is at this stage, we're still analyzing academic literature, but would also be interesting to look at industry approaches, because we have a lot of generative AI applications in industry and also other AI approaches. So when we look at the blockchain enhanced AI, we see that the data and model layers are the two most significant. And underneath these layers for data, we see data and model provenance, secure AI data pipelines. Model is mostly federated learning, coordination, and aggregation. Application is decentralized AI marketplaces and multi-agent coordination. Inference, we have inference verification and audit explainability, and infrastructure and decentralized compute. And then we also see that security for blockchain enhanced AI is lower in comparison to AI enhanced blockchain. Security constitutes 40%. We also have audibility, trust, privacy, explainability, and incentives, which I believe would grow over a period of time. And then it's worth mentioning as well, the blockchains that the studies, the analysis done on is mostly some permission blockchains, but then we also have Ethereum, Hyperledger Fabric, and consortium blockchains for blockchain enhanced AI. And then in terms of the blockchain enhanced AI, we see that there's more spread. For data, we see the categories as federated learning and data sharing, AI data pipeline, and data model provenance. And then this is mostly around the trust, privacy, security, auditability categories. But particularly, we see how blockchain can provide participant identity and contribution tracking via on-chain credentials and tamper evidence pipelines, and also on-chain provenance registry and immutable logs. And then the model layer, we see model registry, sign checkpoints for model training and evaluation, also federated learning, rules for aggregation and validation, and on-chain federated learning through consortium governance and BFT coordination rather. And then we also have the application and inference layer. This is also interesting because even amongst the PhDs, I think Yichen has looked at multi-agent systems. So we see that there's going to be a growing number of these studies from 2024 onwards, given the recent enhancements in, or the recent studies and developments in AI. And then we also have an inference layer, LLM inference, explainable AI, and federated learning inference. And in terms of key insights at this stage of this study, we expect to have a lot more insights, but at this stage, we see that execution and application of interest in terms of AI-enhanced blockchain, as well as the consensus. And then in terms of gaps, we see that the network and data layers of blockchain has been underexplored by AI. We also see that data and model dominates the blockchain enhanced AI side of things. And then also in both directions, we see that security dominates, not just in AI enhanced blockchain, but also blockchain enhanced AI. But particularly in AI enhanced blockchain, it dominates significantly because if you think about on the network axis and also on the application axis, mostly an execution axis, mostly wallet vulnerabilities, smart contract vulnerabilities, and also thinking about other attacks such as DDoS. But AI enhanced blockchain is most on the security axis. And then we also notice a shift to adaptive governance. And as we said before, the emergence of LLM-based blockchain studies focus on smart contracts, auditing, Oracle reasoning, and autonomous contract development, amongst other studies. And then we see also computation as governance in proof of useful work and proof of learning. So this more or less sums up the study at this stage. And as mentioned earlier, we will now be expanding the research papers and also going in more granular to see how we can make the data more rich. Well, we will really appreciate suggestions, and if there are any questions, would be interesting to discuss this. Thank you.
Do you have a question? So you're raising that?
I'm good. I just saw Yimika mention my research, so I'm super happy. So nothing else. Thank you, Yimika. Thank you for giving me credential.
I think this was very interesting, Yimika. Will you be able to share this deck with us? Yeah.
Yeah, sure.
Very interesting.
Yimika, I think this angle is also quite novel, quite interesting that you split into AI enhanced blockchain and blockchain enhanced AI. We see that it's also part of your insights that a lot of the kind of the enhancement or integration is on the high level, right? Not on the low level. Like on infra level, we don't see a lot of research. Do you see where the obstacles lie? Why is it so difficult to for them to integrate?
Okay, sorry, Java, could you just repeat the last
I'm
part?
just saying one observation is that the integration occurs more on the high level as opposed to on the low / infra level, right? Do you see where the obstacles are mainly? They've been discussed in the literature.
I think literature doesn't discuss obstacles, but then we see, I think, originally trends. So initially, we have lots of consensus level papers which touch on AI enhanced blockchain, such as like things related to federated learning, and then in terms of nodes and consensus, and now we see more LLM based approaches. I think we might see this change when more papers are sampled, but I'm not sure if that exactly answers your question, but
Let me ask a related question. I feel I think it's also probably quite self-explanatory why we see more application level integration, because it's just understandably easier to implement. Right? We can easily implement an AI model on any blockchain related problem. But on the infra level, it just requires a little bit more engineering. From what you observed, I understand you're doing a literature suite, but have you looked at the actual deployment of AI plus blockchain integrated solutions? Did you look at actual solutions that have already been out there in the market or deployed?
No. So we mostly looked at just literature at this stage, not deployed solutions in the market.
Yeah, I think that would looking into that would be interesting. Just like what we did before the wallet survey, we also look at the actual solutions, the commercial solutions out there. One thing is what's on paper, the other thing is what's already open.
Yeah, I think that will be interesting as well, especially if we have like an approach to doing it. I know for some of this would be easy to get because on Coin Market Cap, we have like categories and we can easily see what's deployed in industry. So that would be a good source for seeing how we can expand on the applications to identify more gaps and opportunities.
Okay.
Thank you. It was great to see you.
Thank you.
Very much, Yimika.